Alright guys, welcome to 19.2, 19.3. We're going to talk about acids. We've got strong acids versus weak acids, as well even as some bases as well. We'll talk about those. Alright, with acids and bases, the strength of these compounds depends on their dissociation, how much they dissociate. Okay, so percent dissociation is the degree to which an ionic compound separates when you place it in a solvent, okay, when it's going into solution. So most ions will completely separate, okay, go into a cation and anion state. This would be a strong acid or a strong base. However, some of our acids and bases do not completely dissociate into a solution. So their dissociation is less than 100%, and therefore they are weaker acids and weaker bases. So here you can see we have examples. You have hydrochloric acid, HCl, and it completely dissociates into hydrogen and chlorine ions. Sodium hydroxide as well completely dissociates into sodium and hydroxide ions. This makes them very good conductors of electricity, and therefore these are strong acids. Some strong acids and bases that you need to know for your test or quiz are the ones following. Okay, you've got your strong acids and strong bases listed for you. For weak acids and bases, we've already talked about these a little bit. These ones dissociate less than 100%. Okay, usually, as you can see, less than even 15%. That's going to be a sign of a weak acid or a weak base. This means that these compounds don't completely break down into their anions and cations. Some of it's going to stay in the original state, as you can see in our example below. So here you've got an acetate. This is the acid in vinegar, and it breaks down a little bit. The hydrogen dissociates off, but it's still an acetate group in the end. Okay, so yes, hydrogen broke off, but you didn't have it breaking down into more ions. Alright, next we have equilibrium constants for acids and bases. It's basically like the concentration of our acid and our base. So weak acids and weak bases have a small equilibrium constant, which is signaled by a capital K and a subscript EQ. Okay, or for the specifics, like at the very bottom you can see the equilibrium constant for acid is capital K, subscript A. And the equilibrium constant for base is your capital K and a subscript B. So weak acids will have a small equilibrium constant, and our strong acids and bases will have a large equilibrium constant. Alright, in our next few slides we're going to look at strong acids, weak acids, and very weak acids. So in this diagram you can see that our acid completely dissociates into its cation and anion. Okay, you have hydronium and the acid. Okay, its anion state, and so there's none of our acid left over. It's a complete dissociation. Okay, here is a weak acid, and you can see that our acid dissociates, but only partially. And so this is a weak acid. It is only moderately dissociating. And in this last diagram, you have a very weak acid. Very little dissociation occurs. And so this is a very weak acid. It's very far from completely dissociating. All right, and then we end with indicators. Indicators we've talked about, we kind of played with those a little bit in our class, and we'll do more hopefully later on. But these are special compounds that are sensitive to changes in pH. And some are very specific. Some are just for acids, and some are just for bases, where others can test the pH scale for a very large range. Okay, and so the color change indicates a change in pH, which you saw earlier in our 19.1 video, the litmus paper. Okay, it turned red when we had the acid in contact with it and blue with the base. Okay, and so these are used, very useful for determining the pH of solutions. Okay, for certain reactions you have to have specific pHs, and so it's very useful. Alright, that's all guys. I hope that you enjoyed this PowerPoint. If you have any questions, please feel free to contact me. Alright, bye.